Okay, application of junction diode as a rectifier. See, what is the meaning of rectifier? You know, we can convert alternating current to direct current. Okay, or we can convert direct current to alternating current. So the device is used for converting this alternating current to direct current, and that device is known as a rectifier. If you see here, from primary winding and secondary winding, there is a transformer. Okay, transformer is a device which either increase the voltage or decrease the voltage. With that principle only, we can make a rectifier. It's a very simple concept about the rectifier. We have two type of rectifier. First is full wave rectifier, and another one is half wave rectifier. Okay, let's see each thing one by one. First, here is our this is our half wave rectifier. Okay, this is our half wave rectifier. I'll explain you in a very simple manner. Okay, let's see what we have. We have a half wave rectifier. Half wave rectifier. Okay, in the case of half wave rectifier, we have a primary and secondary circuit. We have primary circuit and we have secondary circuit. This is a primary circuit. Okay, there will be a primary coil, there will be primary coil, and there will be a secondary coil. Primary coil, and there will be secondary coil. Okay, so here we have a half wave rectifier in which we have primary circuit and secondary circuit. Okay, and here diode is connected. And with the diode there is a load resistance here. There is a load resistance here. Okay, this is a diode, this is transformer, and this is alternating current. Transformer, diode, and here we have alternating current. This first I am making for input, and second there will be an output. Okay, yes. See, we know that input graph will looks like this always: positive, negative, positive, negative, and this. What about the output? Okay, if you see here, positive, negative will be there. So if you see here, for positive, if the input is positive, that means it will be positive here and it will be negative here, right? Now, because of the transformer, this same positive will be here and this negative will be here. See, because there will be a mutual inductance. Okay. See, this positive connected to positive terminal of diode. Diode can be represented by this, this triangle, where this is your positive one and this is your negative one. If positive is being connected to positive, then it will be what? It will be forward biasing, and in the case of forward biasing, there will be flow of current. So in the first case, there will be flow of current. Now see, if for the second case, current is flowing in reverse direction. If current is flowing in reverse direction, this will be negative, this will be positive, this will be negative, this will be positive. That means this positive is connected, will be connected to negative. This positive will be connected to negative. Like this. If negative is connected to the positive of diode, then this will be a reverse biasing, and in the case of reverse biasing, there will be no flow of current. Then again positive, again current, again negative, again no current. See this thing, positive, negative, positive, negative. In this case, what will happen? Here, half positive, half negative. See, entirely everything is in unidirection only. That means this will be direct current only. But this direct current is, but see, everything will be in direct current. But what will happen in this case? If you want to charge the phone, so if it is taking 10 minutes to full the charge, then it will, if it would have taken 10 minutes to complete the charge, so it will take 20 minutes now. Why? Because half of the time this charging will not work. See here, charging will not work, here charging will not work. So this is half wave rectifier. So this is a disadvantage, that's half of the time it is not working. So what we can do now, we will use a full wave rectifier. Okay, see what in the case of full wave rectifier, there will be two diodes. Here also there will be diode, here also there will be diode. Okay, let's see. Full wave rectifier. Okay, so this was a disadvantage, it was rectifying properly, but there will be a peak voltage, zero voltage, peak voltage, zero voltage. Now, see in the case of full wave rectifier, again input, This is primary. And between the primary and secondary, we have a transformer. This is primary, and this is secondary. Okay. Here also there will be output with a load resistance, with a load resistance, okay. Now this is transformer. Here we will be having two diodes. Okay. Now if positive, this will be positive, this will be positive, this negative, this will be negative, this will be positive. That means, see, input will be like this. Here only I am showing. If input is like this, so at this time, this is diode 1, this is diode 2. Diode 1 will act as a forward biasing, while diode 2 will behave as a reverse biasing in the first case. Okay, that means no problem, current will go like this. In the case 2, we will change everything. Okay, this will be negative, this will be positive, this will be positive, this will be negative. Okay, in the case 2, this will be reverse biasing and D2 will be forward biasing. If this is forward biasing D2, that means current will flow from D2, but it will not flow from D1 because D1 is acting as a reverse biasing. Okay, whatever the factors, but current will flow as there is a forward biasing also. So like this current will flow. Again current will flow. Again current will flow like this. Okay, so this was the successful rectifier. Which rectifier? Full wave rectifier. Okay. You can write the theory, but okay. Now, see, this was there was a this is a rectifier. This is a rectifier, no doubt. But again, our current had not been converted completely as a direct current because direct current was unidirectional also. Here current is not unidirectional. So for making it unidirectional, what we have to do, we have to introduce a filter circuit. This is how the filter circuits look. I will explain how it will work. See, this is your filter circuit. Okay, I had zoomed to the max. Please confirm it's visible to you people. Yeah. Now see, in the case of rectifier, okay, in the case of, see, here alternating current was coming. Here alternating current was coming. Like this. Okay, and it's better I'll make here only. There is a rectifier. This is your rectifier. Rectifier means it will be full wave rectifier. This will be your input. Okay, then here we have a capacitor, and that capacitor is then connected to load resistance, and here is your output. Okay, here is your output, load resistance, and here there is your, and here there is your capacitor. So this is your capacitor, this is your rectifier. This is your load resistor, this is your rectifier, this is your capacitor. Now what? Now what? See. In the case of rectifier, input, this is input will come like this, output will be this. It will be rectified like this, output this. See, here there is a capacitor. What does the working of capacitor? Capacitor is 1 upon 2 pi FC. Okay, capacitor blocks the current. Current have two ways to flow further. Current have two ways to flow further, like this and like this. But we know that capacitor always blocks the current. So current will not flow in this direction. So sorry, current capacitor blocks DC current. DC current. Okay, this is DC. So capacitor, it will move here. Capacitor does not want DC current to move here. That means AC current will flow here. Means that unfiltered part will move here, and here also unfiltered part will move, and that unfiltered part both which cut each other, and directly the only direct current will flow further. Only direct current will flow further. Capacitor blocks DC. And this is how you will get smooth direct current like this. Smooth direct current. Okay, so this was your chapter. Let's see a few questions based on this. The question is, if PN junction diode is reverse, then options are: a potential barrier is lowered, the potential barrier remain unaffected, the potential barrier is raised, the current is mainly due to majority carriers. If a PN junction diode is reversed, then potential barrier is lowered, potential barriers remain unaffected, potential barrier is raised, current is mainly due to majority carriers. Yes, potential barrier is depletion region is increased. That means potential barrier is increased. That means option C will be the right option. Okay, next. In an AC source, voltage is connected in series with a PN junction diode and a load resistance and a load resistor. The correct option for output voltage across load resistance will be photodiode are used to detect. Sorry, I think these are the wrong questions.